So there is another method which we can use to determine the hydraulic conductivity, which is the falling head test. Unlike the constant head test, the setup is relatively simple because in this case here, we're not going to measure the flow of water out of this setup. Okay? But it may be a little bit challenging to do because you will have to perform this test several times because you will need to determine whether your test data are considered as effective or not, okay? Because it may not be easy for you to obtain a reliable value if you perform this test once or twice, okay? So you will have to practice several times before you can obtain a reliable value, and then we will talk about that in a moment. So first of all, for this falling head test, what we are going to do is we have a sample, okay? So water is again flowing into the sample, and then the length of the sample is L, the cross-sectional area of the sample is A. In addition to that, we will also have to have a tube, okay? A tube where water flows in, and then that tube has a area, cross-sectional area, small a. So in this falling head test here, the head is actually varying with time. Okay, so at a certain time, the head may be at h0. After maybe several seconds, then the head may be dropped to h1, and then another time it may be dropped to h2. So what we are going to do is to keep track of the time corresponding to this head level. All right, so again, using Darcy's law, okay, using Darcy's law, you can derive the equation that you need to calculate K. The derivation should be available from your soil mechanics textbook, and it will be given by this equation. A here is the cross-sectional area of this tube, and L is the length of the sample. Big A, capital A, is the cross-sectional area of the sample. T2 minus T0 basically is the time difference for the head to fall from H2 to H0 to H2. Okay, and then it will be multiplied to the natural log of the ratio of H0 and H2. Again, you can look at the derivation from your textbook. So a moment ago, I told you that it may not be easy to obtain a reliable data because there may be an error in the measurement of the head and then also the corresponding time. So, so for this test here, we have a certain standard when it comes to the determination of T0 and T2. So suppose that originally the head is at H0, okay? And then after a certain time, it is at H1, and then certain time later, it will be at H2. So what you have to do is you have to predetermine these three values, okay? So H0, H1, and H2 are values that you pick before the test. And then what you have to do is when you start the test, you will record the time when the water level is at H0. And then the time corresponding to H0 will be denoted as a T0, okay, which is 0. Okay, so you will start your time device when the water level hit H0. And then next, what you have to do is when the water level drops to H1, you will record the time again. Okay, so that will be T1. And then when it reaches H2, then you will record T2. Okay, so as an example, suppose that you have pre-select the value of H0 and H2 as 90 and 40 respectively. Then you will need to calculate the value of H1 using the concept of geometric mean, which is the square root of H0 and H2. So if you do the quick calculation here, the geometric mean should be equal to 60 because H0 and H2 are 90 and 40 respectively. So when you start the test, okay, T0 should be corresponding to 0 seconds. Okay, and then so you will start you will start to record the time. Suppose that at H1 the time elapsed is 12 seconds, and then at H2 the time elapsed is 25. Based on, because the water flow through the same soil type, then theoretically the time it takes to drop from T0 to T1 and T1 to T2 should be equal to each other. Okay, so theoretically, the T1 minus T0 and T2 minus T1 should be equal. But because of some laboratory or measurement error, you may obtain slightly different results. So you will need to evaluate the measurement error. Okay, so if you look at this here, the time difference for the first half is 12 seconds, and then the time difference for the second half is 13 seconds. So there is a difference of 1 second, okay, for the upper portion and the lower portion. So in order for us to evaluate the measurement error, we will need to use the difference in the time, which is 1 second, and then divided by either 12 or 13. Okay, so let's say we use 13, then what you would obtain is there will be roughly 7.7% of error associated with the time for the head to drop in the upper portion and then also the lower portion of the specimen. So, in the lab manual, we have specified that this error has to be in between 3 to 5%. So for my example here, obviously 7.7% is larger than 3 to 5%. So what you have to do is you have to start the test again. You will have to rerun the test until the measurement error is within 3 to 5%. Okay, so from past experience, your senior students will have to perform this test maybe several times, 5 to 6 times before they can obtain a reliable results. So that would be a brief discussion on the principle of the constant head test and falling head test. In a moment, your TA will demonstrate how you can properly read the manometer value, okay, from the setup that is in the next room.